Page 46, please. This is 46. Yeah, 46, 46, 46. Okay. We'll do the best we can with that board. It looks a little sketchy, but we'll deal with it. All right. So we were talking about residuals, yes? And so a residual, when we have points that are plotted, the residual is just basically the vertical component or the distance, page 46. So my friends, the line of best fit is what we would find having data points put in, right? So we have y hat equals mx plus b. Remember, the y hat means that we used data. From the data, we generated a line of best fit or an equation of best fit. So that's why we use the y hat. Is that okay? So if we are above, these are positive values. If we're below, these are negative values. Okay? So that's basically the idea. If you're above the line, you're talking about a positive value. If you're below the line, it's a negative value. The line of best fit is used to use the line of best fit to try and predict outcomes. Okay? So if we're using the line of best fit and our data points are above the line, that means that our prediction is going to be under what actually happened, meaning this. Let's say I go to this point here. I go up to the line, which is here. If I go up to here, that positive value means exactly at that point we actually paid more for something, or we underestimated what our value was. If we were below the line of best fit, so if I drew this pink line up to here, the pink line is going up to the line of best fit. The black dotted line is coming down. Exactly at that data point means that we had over-predicted what we wanted to say, and we actually came out less. Okay? And so over-predictions and under-predictions are great depending upon what we're looking at. Okay? So that's basically what it means. If my data point falls below the line, it's negative. If it falls above, it's positive. So how we figure out those values? Let's use this one. I'll highlight this one as an example. Okay? So a few things. Would you agree with me that there's an XY value that is that point right there? Okay? And then would you agree that that blue dot down there is also an XY value? So there's a distance that is taking place. Now, we're not worried about the X. We're worried about the Y. Okay? So this is going to have a distance to it. And that distance is called the residual. Okay? So we'll call the residual, we'll refer to the residual as R. We're using capital R because I'm not worried about the little r for correlation. Sorry, they had no other letters to pick from. Little r means correlation, means how well our data fits the line. Residual means the distance we are from the line of best fit. If it's above it, it's a positive distance. If it's below it, it's a negative distance. So these values here from the point would actually be x hat comma y hat. And then this is just regular x and y down here for the data point, or for the line of best fit. Okay, so in order to find the residual, we're going to go take the point y value, or we're going to take the line of best fit y value minus the point. Okay, so again, positive occurs when we predicted the value, the response variable is less than the observed. The negative residual occurs when the predicted value is greater. The zero residual means that it's on the line of best fit. So let me do 3 different examples. And these are just made up. These aren't necessarily in your thing. Let's say they all have relatively the same line of best fit. Okay? So if we're talking about that line, the data point for me estimating this x value here, if I come straight up and I come straight over, that's going to give me a y value. Okay? If I also did this, that also provides me something called a y hat value. Okay? Now, friends, would you feel comfortable that my y value that was for me making a prediction using x, called interpolation, that is the same point as the data point itself? Does that make sense? Okay. Now, if I have a second data point that I'm up here, there's a certain value. That's our residual, or R value. Okay. So if I had chosen an x value down here and I came up and got to this point, I would figure out a y value. If I followed this data point up here, that's going to give me a y hat. Okay, so let's just make up values. Okay, these are truly made up. Let's say that this point here is the point 3, 5, and this data point is 3, 7. So the residual equation is R equals y minus y hat. Okay, so y is 5. Y hat is what? If my y value is this, what's my y hat value? Oh gosh, I just went backwards. Oh my gosh, I just went backwards. Oh my gosh, I went backwards. I'm sorry. This is my y hat value. I'm sorry. I just went backwards. I'm sorry. Friday. This is my y value. So I'm going to go 7 minus 5. So we get a residual of 2. Okay, and you can say it's positive 2. You know it's positive 2 because our actual data point. So this is my actual data point. This is my line of best fit. Data point. Okay, so it's positive because it's above it. If I did the same thing here, and let's say I have a point down here below it, this is going to be some xy value, and we'll make something up. And this is my x hat, y hat. Okay, so what would this R value be as far as the sign goes? Positive or negative? Negative. It's below it. Okay, so let's just make up 2 points. So let's call this point from our line of best fit. Let's call it, I don't know, 2, 8. And then let's call this one here from our data 2, 3. So my R value is going to be my Y value, which was 3, minus my y hat value, which was 8. So this has a residual of -5. Okay? That -5 just means my data value is below. So if we are trying to estimate information, the very first one, our estimation and our data point happen to be the exact same thing. We have a residual of 0, an R value of 0, and that's fine. Okay? If my data point happens to be above, mine is below. Now, so Desmos will do residual values for us. Okay? And so let me get my keyboard and jump on Desmos real quick and just make up. Let's say I was comparing shoe size to height. Okay? And it doesn't matter. I'm just going to make up values rather than go around the room having people figure out their height in inches and their shoe size. So let's say I realize I have someone with size 8 foot who is 65 inches tall. And let's say I have somebody size 9 who is 67 inches tall, somebody who is size 9 who is also 67 inches tall. Oops. And then let's go with somebody who has a size 10 who is 70 inches tall. Okay, so I can find my data. Where's my data? Why is it picking on me? What did I do wrong? List. Oh. Stirrup is as bright as a keyhole and as sharp as a marble. I have a Y values that are in the 60s. Nine 67. Oh, let's make a 9 a 68. Okay. All right. So that's what our data does. It appears that has a positive correlation because the slope of that line would be positive. It would have, we'd be able to find the equation. When we find the equation, we can go y sub 1 tilde mx sub 1 plus b. Okay, so I think this will work. This is my first time. Notice how it says residuals here on my graph. I think I can plot my residuals. And my residuals fell there. Okay. Now notice with my residuals, notice my I got an extra column. So where are my residuals? Well, they're way down low. Okay. My residuals are this white blob down here, or this red blob down here. So if I zoomed in on that, all these are talking about are if it's right on the x-axis, zoom in a little bit further on that. If it's right on the x-axis, those red points, that means that those data points fell exactly on my line of best fit. The dot that is above the x-axis, that is a positive residual. The point that's below is a negative residual. Okay, and let me just do this. I'll go y equals 0. So I'll plot that. Just so you can see that dark blue line is the y-axis. So a residual plot basically just says, hey, How far above or below are we? How many points do we have that were a positive value above? 1. How many do we have below? We have 1 below. How many are right on the line of best fit? 2 of them. Okay, so that's basically what Desmos can do. And how you get that is once you plot your stuff, if you want the residuals, you click plot, and then you have to find the residuals because the residuals are based on the distance above or below the x-axis. Again, if it falls right on the x-axis, it will do well for you. Why are residuals important? So if you understand the relationship between two variables, so in our case, we're doing a fictitious shoe size versus how tall somebody is in inches. So between two variables is building a model regression equation allows you to predict one from the other. Understanding why the model is making errors may help you understand the relationship between the variables to better and even build a better model. For example, let's say you have a system for predicting the winners of NFL football games. Ooh, that would be good for Vegas, wouldn't it? Or any of your online betting stuff. I like it. Hypothetically, let's say your system predicts winners correctly 70% of the time. If you want to improve your system, you'll need to study the errors that you're making. Is there something you're missing? Maybe you'll discover that you're underestimating teams for a certain division consistently. Understanding the pattern, your errors will allow you to adjust and potentially build a better method. Okay? You guys have all heard of counting cards, yes? Now, there are very easy ways of counting cards that gives you a slight advantage over the house, and there are more advanced techniques of counting cards that give you a higher advantage. A very simple way to count cards, and I kid you not, in the game of blackjack, you're going to count up to 16, okay? Face cards and tens are worth 0. All the other cards are worth their value. That means an ace is worth 1. So if you're counting cards and you're able to see the cards that are on the table and it's coming out of the same deck of cards on the next draw, if you count cards, if your count ends at 14, 15, or 16, 14 gives you a good advantage, 15 is a better advantage, 16 is the best advantage. That more face cards are in the deck, meaning you could improve your deck or improve your bet on the next bet, and it's going to increase it. Okay? Now, the sum of squares relationship is a little bit bigger. Let's see. What the sum of squares basically is, we go with this. So we have our line of best fit. If I had a data point below or I had a data point above, the sum of squared, so your r squared value, that's the one we ignored for a while. The r squared value is generated basically by drawing a vertical component and making a square. Vertical component and making a square. So this square has an area, this square has an area. Okay? Area and area. What do you know about area? If you're multiplying a real area, area has to be positive. So the sum of squares would mean you're adding up the boxes or the squares that you've made. Okay, and that's where you generate your r squared value. Your r value is just your vertical component summed up. So your r value can be negative. Your r squared value always has to be positive because if you find an area of something, even if you have like a -7, -7 times -7 is positive 49. Okay? So that's about as far as I need to go for today. So let's take a look what we can, kind of opportunities we can go. So is it still correct that Tuesday is a ditch day? Okay. I'm making sure. I'm just trying to make plans. Not saying I'm against it. I'm just saying I'm making plans. 2426, 2426. 27. So let's say we're going to have page 153 and 154 due Wednesday, because you told me Tuesday's a ditch day, right? So what we'll do is on Monday we'll go over some of those, and then on Wednesday we'll go over the rest, and that's when I will mark it off. Does it sound like a plan? All right.